Calculators are very, very, very important because you're going to type some stuff in, and magically it's going to go poof. It won't say poof, but wouldn't that be great if it did? Like little, I don't know, sparkles. Yeah, came out, and then like, ching, and then there was like your equation. Wouldn't that be great? Like not real sparkles because class would be messy, but like holographic sparkles. You know? That'd be great. I also wish your calculator would scream at you, be like, no, idiot. This is a negative sign, not a subtraction. Go back, try again. Like, I would actually be okay with the calculator belittling me if it fixed my problem. You know? Like, if the calculator's like, no, dummy, your window's not big enough, I'd be like, yes, thank you. Thank you. I would be belittled by my calculator if it fixed my window for me when I was in high school. It was like, change it. I'd be like, you're right, sir. Didn't be mean. Or ma'am. Because it was mean. I feel like I've talked to it that way. All right. So we're on this page here. And you have the steps in front of you, the second page, correct? Okay. So on the second page, what we're doing is called a regression. What a regression does is it takes data for x data and y data. So these are just coordinates. X data, y data, x data, y data, x data, y data. For every x, you have to have a y in order to input it. If it only gave you an x and didn't give you the corresponding y, we couldn't put that coordinate in. If it gave you only the y and then left the x empty, couldn't put that in as well. So those ones we have to leave out because we need an x and a y that goes with it. These are just coordinates in a table, okay? So regression puts coordinates from a table into your calculator and poof, gives you out an equation. It's the most wonderful thing. So what we're going to do first, though, is we are going to make it so that our calculator has an r-squared value, which is called the correlation coefficient. Before we turn that on, I'm going to show you what a correlation coefficient is. So if I had data, if I took a pen first, not being a dorm, I don't adapt every day, same thing. So say I have data like this, and I ask it to do a linear regression. It's going to do a line of best fit, correct? Like this. Pretty okay, but how much percent of the data fits on that line? None. But it's pretty close. It might say it's an r-squared of 0.6 or 0.7. Like 70% of data is close, 60% of data is close, which means the equation's okay, right? If I put a quadratic in here, my r-squared would be very low, 0.1, 2, something like that, because this doesn't really fit a quadratic, does it? If I had something like this, and it did a regression for it, it might be like 0.0999999, because 99% of the data fit on that line. That's a really good r-squared value, right? So the closer your r-squared value is to 1 is how much better the data fits that equation you picked. Does that make sense? So we're going to turn that on. Now how we turn on the r-squared is actually in B. So if you look at B with the bullet, right here, once you turn the r-squared on, you don't have to do it again. So it's great. You do it once, you don't have to do it again unless you reset your calculator. So you're going to go second, and then the 0 button, and then you scroll all the way down, it's alphabetical, till you get to diagnostic on, and then you hit enter. And then it should say what? Done. If it doesn't say done, you have to hit enter again until it does say done. So we go second, 0, all the way down to diagnostic on. Oh yeah, I got a little excited because I was listening to her X before C and looking for it and got distracted. Diagnostic on. Oh no, I'm in the graph. That's disappointing. I need to be on here. Oh yay, I get to do this again. So excited. Now where's the X thing you were asking me? Oh, because tests. Don't ask me why they did that. It's because it's italicized maybe. I don't know. It's really dumb actually, hey? Yeah, kind of dumb. Oh wait. Good? Now, let's look at our actual data. Everyone's looking at the data? So this is actually a 1 hour record. The 1 hour record is the farthest distance traveled by bicycle in 1 hour. So the table below shows the world record distances and the dates they were accomplished. They're getting further in an hour. How is that possible? Do you think the humans are just getting better? Yeah. I would say better bike. A better bike, for sure, than the humans. Yeah, maybe they're getting better in what they're doing and preparing better, and they have other things that they know work better. But I'd say a lot of this is probably due to a better bike. And a better bike. All right, so what we're going to do is, this gave me a coordinate. This here is just a coordinate, right? The coordinate is at 1996 and 78.04. Right? This is my x, this is my y. Do we agree? It's just a coordinate in a table. That's sideways. If I can get you to understand that, that makes a lot more sense. Do you understand that it's just a t-table sideways? X, y? So every x has to have a y, and every y has to have an x. So if I actually gave you like this now, say I went 2010 and left this blank, could I put that in? No. So if you have an x without a y or a y without an x, they might be making you find that y, but we don't actually fill it. So today's lesson is literally just this. This is what we're going to do. We're not answering any questions. We are going to get an equation, which one they tell us to find, linear, quadratic, or cubic, and then we're going to get that graph to show up on our calculator. Literally all we're doing today. We're not answering any questions. We're doing a two-part process because when I used to do it and then answer questions, it's super overwhelming. But if we just practice getting the equations and getting it to show up in our calculator, life is good. Ready? All right. So this one wants a linear regression, so we're going to follow all the steps on this page. So step 1, enter data into lists. So we need to enter the data into lists. If you were in 20-2 and you did statistics, same lists. So we go stat and then edit. So we go stat. Stat is right here, beside the xt theta n. Stat, edit. Now, put down your calculators and pay attention. This goes real bad real quick. If you delete a list, not the end of the world, I'll reset your calculator, but I will be disappointed. I'll walk over to them. You didn't listen, girl. You know, listen. I told you. Yeah, just disappointed. I won't be that disappointed. I'll just reset your calculator. But we're paying attention. Do we want to clear lists or do we want to delete lists? Clear lists. Right? We're all paying attention. Do we want to clear lists or do we want to delete lists? Clear. You guys will press delete enter and you're like, well, I don't know why it went away. I'm like, you deleted the list. That's why it went away because you pressed delete. See how that works? So if there's data in your list, you go to the top and you press clear, because I want to clear the list, enter. Not delete the list. See how that works? You want to clear it? I'll be disappointed and then just reset your calculator and get it back. Boom. And then you'll have to put the category back on and get your diagnostics back. All right. Everyone's lists are empty? Now you're going to input your x's into the list 1 always. So 1996, enter. 1998, enter. What happens if you put something in wrong? It's just going to fix it for you and be like, no probs. It's going to give you the wrong thing. Yeah.
Mine says 2E3 when I entered 1996.
You're going to reset your calculator because you're in scientific notation, and that's the second problem you've had in this class, so we're just going to reset it.
Oh, okay,
So,
because, yeah, I'm doing physics. And I had this
yeah. So go second, plus sign, number 7, over 2. All right. Okay. I can show you how to fix the scientific notation if you'd like to.
That's
So
good
right
to
now,
download and
yeah.
put it back to standard instead of
Yeah, yeah. So you did done that. But because we have 2 little things going on, I'm just going to reset it so we don't have like a third. So like now the equation doesn't pop up. Physics. Just kidding, I actually really liked physics. Okay. 1998, 1999. 2002. 2003, 2004. They skipped. You think 2006 was the problem? What about way back here when they skipped 2000 and 2001?
Oh, I was born in 2006.
I started teaching in 2006. It's important. Makes me old. I'll take it. It's okay. 79.14. So when you're done, just double check your numbers, because if you do have a decimal off, you will get the wrong answer, and then all your answers will be wrong because you got the wrong answer. Fun fact, I started teaching in 2006, and I was, I'm recording, that's what I forgot. So on here, enter data into list, check. We have to be able to do this without thinking. Remember, we have to be able to know all the steps without looking. Can't look. Because what we're going to do here is we're going to do linear, quadratic, and cubic, and they'll feel overwhelming at first. But trust me, whenever anyone gets regressions on the diploma, they're happy, because by the time you've done them this many times, you actually think they're easy. Then we have to do log regressions, exponential regressions, and sinusoidal. So we have 6 different types of regressions by the end, so you do have it memorized. So don't let the overwhelmingness of the beginning mess you. So you got your lists, right? Okay, cool. We have data into lists. We don't actually have to do number 2 each time, so this one's like a little caveat to B. Now, we have to figure out what the heck polynomial type we want, which it said linear, right? So we're good with that. But we want to calculate something. We want to calculate a regression. So we go from A right to D. We go from here right to here. A right to D. So we want to calculate something. We want to calculate a linear regression, correct? So we're going to go stat and then calc, because we want to calculate something. So we go stat. Instead of edit, we go over to calc. Paying attention? So for this unit, are you paying attention? Because you guys have picked a different one. For this unit, we are using 4, 5, or 6. Linear, quadratic, cubic. People are like, can I use number 2? I'm like, sure, you're going to be wrong. Can I use letter B? You're going to be wrong. You can use them. I'm not like anti-against them, but you'll be wrong, because this unit is 4, 5, and 6. Okay? So it's really nice in that way that we have 4, 5, and 6 are the only ones we can use. My students made a cheat for themselves. Do you see it up there?
Yeah.
4, 5, 6. 9, 0 is exponential and logarithms, and C is sinusoidal. They said if it's artwork, you can't take it down.
They're not wrong.
They are not wrong.
It looks pretty.
Yeah, right? Looks like a license plate, but it's actually a cheat. And it's artwork, so can't take it down. So we're picking linear regressions, which is number 4. Now, let's go back here. So we picked number 4. So we did stat, calc, right? We did stat, and then we moved over to calc. Then we picked linear for this one because it said linear. People are like, how do you know? How do I know? Because it says linear, right? Right? Little giveaway. Okay, so we pressed linear. Now, we are all actually going to just use the older calculators. The newer calculators, we can do it a different way, but the older calculators works for everyone, so we're just going to do the same thing for everyone. Okay? So, you're going to go, if you have the newer calculators, you got a screen list like this, correct? You're going to go and press enter. Arrow down. It's frozen. Why are you frozen, son? Oh my gosh. No. Enter, 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 enter until it says calculate. I don't know what mine hates me. Oh, it's because my whole thing is frozen. Nope, I don't know. Yeah. Enter. And you get it to pop up. If you have the old calculators, you press enter and they'll pop it up right away. Linear regression will be on your screen. LinReg, hit enter. And the equation pops up.
Yeah.
Mine doesn't have the R, it just has A and B.
Oh, it doesn't have an R because you pushed it.
0. Yeah. Yeah.
Okay. Okay. So the R squared is what we care about. The R squared says 96% of this data fits. If you're like, wow, the quadratic gives me a higher R squared, cool. It asks you to do linear. You have no choice. Okay, you can't be like, oh, the R squared was better for quadratics. Doesn't matter. If they ask for linear, you do linear. All right. So we have this equation in front of our faces. Does everyone have it, even on the old calculators? On the old calculators, it'll go lin reg, and then you hit enter, and then it spits it out. So does everyone have an equation on their screen? Screen? Everyone has an equation? Everyone has an equation. Your equation might look different if you have the TI-83s. Totally fine. You still have an equation on your screen. Okay. It is, looking here, linear. It's saying that the form that we have is linear. It's y equals ax plus b. If I had to write out the equation, and they say round to the nearest hundredth, let's say, a would be 0.86 x minus 1,635.73. That's how I would write out the equation. It gives you your a, it gives you your b, and it gives you the format you got to fill it in. Okay? Now, it would stink to have to write down all those decimals on a piece of paper and then retype them in y equals. Plus, that's not all the decimals, that's just what's showing up on my screen. Right? There's got to be a better way to get it to go into your y equals for you. And that's this right here. So you want to get that equation into your y equals, correct? So you're going to press y equals. Clear out stuff if you got stuff in it. You're going to press y equals. Is everyone in their y equals? Okay, then it says to press vars, statistics, over to equation, and then enter. I'll show you what that means. So we're going to go into our y equals, vars, down to statistics, or just press number 5, over to equation, and now it's putting the regression equation into where? Y equals, because you press y equals, correct? And it puts it in there for us. So it seems like lots of steps. It does. You will have them memorized. We're going to practice and practice and practice. Does everyone have it sitting in their y equals? Now press graph. Wow, I'm seeing nothing.
That sucks.
Why am I seeing nothing? I have negative 10 to 10, negative 10 to 10 is my window. But my x starts at 1,996. Weird, right?
Yeah.
And my y starts at 78. Now, I'll be the first to admit that when I was in high school, I hated windows. I was like, windows are the death of me. Windows and fractions and terms and commas. Kind of the death of me. That's what I felt like. First to admit it. Okay? Windows should not be the death of you when you are given a table of values, because the table of values helps you figure out what your window should be, right? So let's look at the table of values before we decide our window. So on our graph here, we're going to decide. So what's the lowest year we have here? 1996. Now what if they ask me something from below that? Like what if they ask me 1980? I would have to make sure that my x-min would be 1980, correct? So I always go a little bit below. So if my lowest x here is 1996, I'm going to pick 1980 as my x-min. Right? What's my highest x? 2009. So I'm going to make my x max maybe be 2020. Is that sheer guessing, or do I have a table of values with data in front of my face? Table of values with data. Life is way better when you have data, right? So I'm going to go to my window. I press window, and my x minimum I'm going to make be 1980, and my x maximum be 2020. You can leave your x scale at 1 if you want to. If you do, it'll just be a solid black line, because there's going to be like one tick between 1980, 1981, 82, 83, 84, 85, 86, 87, all the way to 2020, right? So like when I press graph, I do have some ticks going on here. If it's a solid line, you might want to make them smaller. It's up to you. Okay. Or bigger, I mean. Let's look at the distance. Let's talk about distance for once. What's the lowest you can go to as a distance? 0. So should we start there, and then we know that we'll for sure cover all the stuff below wherever the heck we are. So I'm going to make my y min be 0 because it's distance, and distance can't be negative. Oh, the woodpeckers are back. That is the woodpecker. What's the highest this goes to? 90.6. Now, when I go to the end of this line, it actually is the highest. But you guys, you have to actually look within the data and see if there a higher point. Now, because it's linear, the highest point will be at the end or at the beginning, correct? But if it's quadratic, it might go like this. It might go high in the middle and then come back down, right? So you don't want to just go look at the last data point and say, oh, it has to be higher than that. The highest point on here is 90.6. I do see that. Okay, that confirms it for me. I need to make my y max bigger. I'm going to do 120. I don't know, I wrote kilometers, but it's because it's in kilometers. So I'm making it be 120 because I want to be able to extrapolate data from this. Interpolate is data within the data values you're given. Extrapolate is outside. So I'm going to go, I'm going to make my y min be 0 and my y max be 120. Graph. Now the ticks are pretty close together, so if I want to, I can leave it as a y scale of 1, or I could make the y scale be every 10 that there's a tick, because the scale just means every 10 I'm going to get a little tick. Every 10 I'm going to get a tick. Every 10 I'm going to get a tick. So you could leave it at 1, but we couldn't really see them, or when I make it 10, I can actually see the ticks. Right? Everyone have it showing up? That's all we're doing today. We're just literally trying to get it to show up. So, oh, guys, show up? That's our goal for today. Okay, paying attention. How do people error? They'll get an equation, they'll get a graph, they'll answer their questions, then they'll go to their next question, and they will get an equation, they will forget to put it into the y equals, and then they'll answer their next question off of the previous data. Right? So what I will always say to you is when you're done a question, go to your y equals and clear it out. Every single time. So that even if I find a new equation, unless I insert it in there, I'm going to press, as though it's funny. People are like, Mrs. Lepp, it doesn't work. The graph isn't showing up. This is what they bring me over. And then I say this. I go, press your y equals. And then they press their y equals and they're like, oh, no equation. I was like, yeah, no graph can show up. You don't have an equation in it. Okay? So always in between questions, go to your y equals, clear it out. Okay? So let's go to our next question. Our next question is this. It's not that. It's this. Matt buys t-shirts for a company that prints art on t-shirts and then resells them. When buying the t-shirt, the price Max must pay is related to the size of the order. The consistent data will always be your x, and then the decimally data is your y for linear, quadratic, cubic. So this one wants a linear regression again, right? So we go back up to A. What does A say to do? Stat. I want to enter data into my list, right? So I go stat. Come on. It's frozen again. Love it. Go stat edit. Stat edit. And do I want to delete lists or clear lists? Clear lists. So I go to the top, I press clear, enter, I go over to the top, clear, enter. Right? Then put your data into the list. Once you have your data in your list, stop. So we're all in the same place. Everyone have their data in their list? Okay, now we want to calculate something. How do we do that? Stat? Calc? Which one? 4, 5, or 6? 4, because it said linear. Enter, 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 enter. If you have the new calculators, if you have the old calculators, it'll go linear, right? You hit enter, it pops up, right? Either way, we all have to have some sort of equation sitting on our screen. Do we have that? This one has an r-squared value of 1. That means 100% of this data lands on that line. This is the best you can possibly have. Every data point lands on that equation. Right? That's pretty dang good. Okay. Cool. I have myself an equation. So that was A, was to get the stuff into the lists. And then check. Then it was D, to get the equation to show up. Right? Then we go to E, to get the equation into our y equals. Correct? So we want to get this equation into our y equals. So we press y equals, because that's where we want to get it to. And we want to get regression equation into our y equals, correct? So I have to press buttons until I can get regression equation, and then they'll pop into there. What buttons do I press? Well, it's under E for older calculators. You press vars, statistics, which is number 5, over to equation, enter. And it's there for you. Does everyone have it sitting in their y equals? And now we're good. We press graph. Oh, dang it. We're not good. What do we have to do? We have to get the regression equation. We have to get it into our y equals, and then we have to get it to show up by doing what? Change your windows every time. So those, no matter what regression question I give you, that has to be done before you answer anything. Get into lists, get your equation, get it into y equals, change your window, then stop and read what the heck it wants you to find. Make sense? Okay. So we go to our window, and we have to make our window fit. So let's look at this data here. So for my X minimum, they didn't list these in order. What's the lowest number of shirts I have? 200, and I'm selling shirts. So what's the lowest I could sell? 0. So I can make my X min be 0. Or I can make it just be below 200, like 100 or 50 or whatever. Correct? What would be my X max? 740 is the absolute highest, so maybe make it be 1,000? Make it be higher. I sometimes double it. I sometimes make it be 1,400 or 1,500. Because I can have more data. The catch is if you're trying to find like the cost per shirt of 1,200 shirts and your X max is 1,000, your calculator is going to fight you and say it can't do the thing. Which I wish it would be like, hey, girl, you need to make it higher, the X max bigger than 1,200. Wouldn't you be happy if it actually told you what you need to fix? The best thing ever. It would have made my life so much better. All right, but it doesn't. Cost per shirt. What's the lowest cost we have here? $1.95. What's the lowest you could pay for a shirt? 0. And then Y max, the highest the shirt cost is $5.20, and it's more money when you sell less shirts, obviously, right? Because that's how the quantity works. You pay more when you buy less. So it's at $5.20. Maybe make it be 10, which might be aggressively big for it. Definitely, yeah, it's Y max. So my X min's 0, my X max is 1,000. My Y min is 0. My Y max, sorry, is 10. Now, if I look at the ticks, I'm going from 0 to 1,000 on my X. Wow, that's a solid line. Right? That's because I have 0 to 1,000 ticks in here. That's 1,000 ticks along that little tiny line. Well, if you do 1,000 ticks, they just connect each other and make a solid black line, right? Not the end of the world. You can leave it like that, but if you don't want it to be like that, and you want to be able to see the ticks, maybe make your X scale, each little tick be worth 100 maybe, from 0 to 1,000. Now I have 1 every 100, and now I can actually see the ticks, right? And then here I have from 0 to 10, and then I have each tick worth 10. Well, it's probably better to have each tick worth 1. Yep. Now does it show up? Yeah. Do I have the graph? Yes. Very good. Okay. Moving on to a new question. What's the first thing we do? Go to our y equals and clear it out. And why do we do that? So that I don't accidentally use that equation for all of my next questions, right? If it's gone, I can't use it. So I go to my y equals, I clear it, and then I go look at the next question. The next question is number 3. The world record for the men's 100-meter sprint was 10 seconds in 1960. The table below shows the world record time since 1960. And it wants a linear regression. Remember I told you we're not answering any questions right now, we're just trying to get it to show up. Because when I made you do graphs and answer questions like 5 years ago, I lost people. It was like the worst class. I hated teaching it. This class was like terrible because everyone was just overwhelmed. So I was like, change it. So that's what we're doing. We're just getting it in. So this is going to be our x. This is going to be our y. Go type it into your calculator. Clear your list. Don't delete your list. And try and get it to show up on your graph. And what do we have to make sure we do? Change our windows always, right? Okay, try it out. So your y equals, you give it into here. Window, I would make x min be 0 and x max be 100. Double it. Make that 10. And then my y min is time, so I make it be 0. And then if you go up to 10, you can do 15, whatever, it doesn't really matter. And then press graph. Should look something like that. So as long as you can get some sort of line showing up, you're in pretty good shape. Yours is just a little higher. As long as the line going down, it doesn't really matter. I could make my y max be 20, and it will look like that, right? Like it's still a line, straight line going through. Okay? Yeah. Yes. So we're moving on to the next one. We're going to press y equals, and we're going to clear it. Right? That's our very first step. Now we're actually bypassing example 4. We're not doing that right now. We're going to go to example 5. Why would I switch to example 5? Because it's what? Yeah, it's not 4. It's going to be number 5. Linear quadratic cubic. So we're going to be doing number 5. So when we do stat calc, we're going to pick number 5 now, the quadratic regression one. Okay? Trying it out. So we're on example 5. Josie hit a golf ball from the top of a hill. Golf ball goes up and comes back down, right? Quadratic regression makes sense in that instance. Another thing that kind of helps you with quadratic regression is your y values as time goes by. Your y values go up in the air and then they come back down, right? That's not linear. So I start at 52.5 at 1. I didn't start there. I start earlier, but 52.5, 73.2, get higher, then lower, then lower. So I'm going up, then I'm coming back down as time is increasing. Right? All right. So I have my data, maybe, and I go stat, calc, but now I'm picking quadratic, which is number 5. Then I go to my y equals, I go var statistics over to equation, enter, and put it in there. And I look at my data. So my time, the lowest it can be, x min, is 0. My x max, I'm going to double, so make me 10. My y min is height, so I'm going to make it be 0. You could make it be 25. Actually, that's a lie. You could make it be 8 or something below 16. Lowest is 16, so I'm going to make it be 0. My y max, I'm going to make, now some people will say, well, at 74.6, it can't go any higher. Well, between 3 and 4, it could go higher. It could go to like 75 or 74.8, right? And then come back down or whatever. Or between 2 and 3, it could have went higher, right? So I'm going to make my y max be 90. It's not that essential, it just needs to be higher. So 0 to 10, 0 to 90 is what I chose. It doesn't have to be that. 0 to 10, you can go up by 1. 0 to 90. Boom. And you have quadratic in front of you. Does everyone have a quadratic? Quadratic, quadratic, quadratic. You have a 3, 2? Nothing? Okay. Now you're going to be sad, but that's okay. I'm going to be fine with it. We're moving on to the next question. What do? Y equals clear. Now, The reason why I picked this massive amount of data is because sometimes they give you two lists side by side, you will be okay, I promise. But can you pay attention to this question? Because sometimes they put lists side by side like this, and people think that they're separate lists. They're not. They're just trying not to use an entire paper. So what this is this is years after 1979, so is this. This is the price of gas, so is this. So instead of using a whole paper, they just put the list side by side. But in reality, this could just go underneath here, and this could just go underneath here and make it a really long table. Do you see what I'm saying? Does everyone understand what I'm saying? So this is list 1, and then this is list 1 continued. And this is list 2, and this is list 2 continued. And this time they want a what? Cubic regression, which is number 6. 3 is linear, 4 is quadratic, 6 is cubic. 3, 4, 5, 6, right? 4 linear, 5 cubic, or 5 quadratic, 6 cubic. So we're going to pick number 6. Let's try it out. So everyone should have that kind of equation sitting in front of your face, and then with those numbers, and then we go to y equals, and we want to put it here. So we go, how do we get the equals in? We need to, in y equals, need to get a regression equation. So we press vars, number 5, over to equation, because it gets us a regression equation, right? That's why we go there. So it's a regression equation into the y equals. Okay, then I told you we also have to make sure that we change our window. So our year that we start is 0, and then we go to 29. So I'm going to go 0 to 60. And then our y min is money. So I'm going to go 0 to, looks like 115. I'll go 150. And mine looks like that. Okay, one thing I want to talk to you about. This one, everyone put your pencils down. I'm going to get you guys to pay attention so I don't lose you. Because these are two different styles of asking the same thing. Ready? Everyone paying attention? So when I go back to this one, the year is 1996. So if I want the year 2000, I would put in 2000 to get my answer, correct? Because 1996 is the year 1996, 1998 is the year 1998, 2000 be 2000. I would type in 2000, it would spit out an answer, which is what we're going to talk about tomorrow. Because this gives the actual year. 2000 would go in as 2000. We agree? But the one we just looked at, it was the years after 1979. So what does 0 actually represent? 1979. What does 1 represent? 1980. 2? 1981. So if I want the year 1983, would I put in 1983, enter, and get that? No, I would put in the number 4. Because this is years after 1979. So if I want the year 1983, if 1979 is year 0, 80 is year 1, 81 is year 2, 82 is year 3, 83 would be year 4, and that's what I would look for. They're very different. The other question actually physically gave you the year, and you put the years in. So if I wanted 1983, then I would go 1983. Boom, right? This one says years after 1979. So if I actually wanted 1978, what would I have to put in? -1. Yeah. Pardon? Yeah. Exactly. Okay. One last one I want you guys to do. You're starting a new question. What are you going to do? Clear your y equals. This is your x. This is your y. What type of regressions? What type of regression? Cubic. Which number are we picking? 6.